Hello everyone. In this video, I will guide you through the basic tool and drill setup in Woodsoft nesting. This is the interface you see when opening the basic tool and drill setup window. 1. Creating a configuration. First, we need to create a configuration name. Enter any name you want. Then select Save Tool and Drill Setup. When the system displays, OK, successfully saved, the configuration has been created. 2. Tool list setup. Next, we define the tools used on the CNC machine. The tool number corresponds to the tool's position on the machine. For example, a 4-head machine will have T1 to T4. For machines with drilling blocks, the numbers may be from 11 to 19 or 21 to 29. Enter the tool diameter, and choose the tool type, cutting tool, drill bit, or V-bit. You can also add notes to help identify tools quickly. For example, if you add tool T6 with an 8 mm diameter and set it as a cutting tool, you may add a note like, cutting 25 mm board, to make it easy to recognize later. 3. Cutting process settings. Now we move to the cutting process setup. Here you select the processing type, such as external contour cutting, internal contour cutting, grooving, or pocketing. Depending on the type you choose, the system will allow you to select a tool number from the cutting tools defined earlier. The rotation velocity is the spindle speed. For example, 24.000 rpm is common for standard panel cutting. The cutting velocity is the feed rate used when the tool is cutting material. If you set the cutting feed to 8000, the G-code will show F8000. The slow cutting velocity is used near the end of the contour. This reduces speed to improve accuracy. For example, slowing from F15000 down to F3000 helps prevent tearing at the final edge. The moving down velocity is the plunge speed when the tool moves from rapid motion into the material. This value appears as the F speed during the first Z cut. Next are the depth settings Z0, Z1, and Z2. Z2 is the initial cutting depth. Z1 is the intermediate depth. And Z0 is the final depth. For example, Z0 equals 28, Z1 equals 15, Z2 equals 3. Means the tool will lower from 3 mm for the first pass. Continue at 15 mm on the next pass. And finish at 28 mm on the final pass. The maximum processing depth controls how much material the tool removes in one pass. If you set it to 20 mm, a board thinner than 20 mm will cut in one pass. A 25 mm board will cut in two passes, 20 mm plus 5 mm. For grooving, the software uses the minimum and maximum slot width values to automatically detect right widths and choose the appropriate tool. Example: if your groove is 4 mm wide, and tool T5 has a diameter range of 3.8 to 5.7 mm, the system will automatically assign T5 to that groove. 4. Drilling process settings. Next is the drilling setup. Choose the drilling method, such as standard drilling, circular drilling, or circular pocketing for holes like hinge cups. Select the tool number you want to use for drilling. If the hole diameter matches the tool's diameter range, the software will automatically assign the correct tool. The rotation velocity is the spindle RPM for drilling. The cutting velocity is the drilling feed rate. The moving down velocity is the plunge speed. Depth values Z0, Z1, and Z2 function the same way as in cutting. The maximum processing depth determines how deep each drilling step can go. This is important for deep drilling or hardwood to avoid tool overheating. For example, if drilling a hinge hole, you may choose circular pocketing so the tool removes all internal material cleanly. 5. Profile on settings. Finally, we have the profile on settings, used for special toolpaths defined in SketchUp. Start by selecting the layer containing the profile on lines. Then choose the processing type and the tool number you want to use. Set the processing depth, the rotation velocity, the cutting velocity, and the moving down velocity. You can also set Z0, Z1, and Z2 for profile on cuts. as well as the maximum processing depth, just like in the cutting section. If a profile on line is marked as run first, it will be executed before all other toolpaths. This ensures the profile on groove is processed before cutting or drilling starts. Example: if your product has a decorative groove that must be cut first to avoid tear out, set it to run first so the CNC prioritizes it. 6. Saving all settings. After finishing all settings in the tool list, cutting, drilling, and profile on sections, click Save. When the system confirms success, your tool and drill configuration is complete. Thank you for watching.